Hello, good evening, and thanks for joining the June NYJavaSIG event. We're very happy to have you with us tonight. Please, during the presentation, use the chat to treat with the presenter. Ask as many questions as you want. We want to make this very interactive, so we also learn from you, and we want you to have the best experience out of this presentation. So go now, give a try, tell us your name, where you joining from, and if that's your first time attending an NYJavaSIG event. As always, we would like to thank our sponsors, JetBrains, which give us a few licenses that we're gonna be raffling tonight. So stay tuned to the presentation. We're going to be asking questions, and at the end of the event, there will be also another raffle where we're going to be giving license away. And here, the Agile Learner is from our good friend Venkat Subramanian. It has a lot of great content, and we will be raffling a 1-year subscription as well. So please follow us on social media. Here's our website, javasig.com, and we are more active on Twitter at NYJavaSIG. So you can follow us on the social media to be notified about future events. We have monthly events and we have hands-on workshops. So follow us to stay up to date with everything that we are doing. So tonight, we will have a good friend of mine, Neha. She's one of the leaders of NYJavaSIG and the Garden State JUG. She's very active in the community. I'm happy to have share presentations with her. She also participated in the Java in Education initiative, and she's going to be talking about a very interesting topic, pattern matching, which has had a few releases and is constantly being updated. Very interesting topic. I hope you enjoy. As always, use the chat to ask questions. Neha, stage is all yours. Welcome. Thank you.
Thank you so much, Rodrigo. First of all, happy birthday. And I really appreciate your time. Even on your birthday, you're joining us. So we'll definitely celebrate. And welcome, everyone. New York JavaSIG is like my home, actually. I started actively participating at New York JavaSIG 2 years ago. So it has been a long journey so far. Very helpful during pandemic, to be honest. So, okay, let's get right into the topic first. Rodrigo, can you confirm if you can see my screen right?
Yes, all good, Neha.
Perfect. So pattern matching is a very interesting concept because the mechanism it involves checking for a value against a pattern. So you already know a pattern by whatever your use case is, and you want to recognize any value that you're checking against your pattern. So that's the standard definition of pattern matching. Once you match a pattern, you want to do some stuff with it. So that's what it is definitely known as. Pattern matching for Java is a little different right now because you may have seen pattern matching already. A lot of languages already implemented it. It's not a new concept at all. Haskell has it, Scala has it for many years now. C# also introduced it a couple of years ago. So it's almost there. And even though we are a bit late to the party at Java, but it's still like, it has been a progress, like step by step with different features coming in Java. With 6 months release cycle, it's always an easier way to look at the preview features and try it out and get familiar as a developer, and then use it when it goes live in production. So we'll look at this pattern matching, all the changes that have come in, and a few more changes that are going to come in. So here's the brief agenda. I cannot talk about pattern matching without talking about Project Amber and algebraic data types, since it's part of it. We'll also try to understand why it is important for you to learn. Like, it's been there for a couple of releases now, but you need to, as a developer, understand why you should learn about it. It's mostly there as instance of operator. You can use it with switch statements and expressions as well. So we'll see those usages along the way. We also have types of pattern matching, which are there right now with Java. So we'll see the brief overview. And we'll see the upcoming patterns in Java. This is something which is coming in the new releases, and some things might change, but I'll still give you some overview of what you can expect Java to become when the pattern matching more features are released. Brief introduction. I work at Morgan Stanley. I'm a vice president. I still write code, and I love to write code. I'm also a fellow JUG leader at Garden State JUG user group in New Jersey and NYJavaSIG in New York. And we hold monthly events, so you are free to come. We are very interactive. We are going in person pretty soon, hopefully. So keeping our fingers crossed. I want to see everyone in person again. I also write Java-based application for almost 14 years. Seems pretty old now. I love to travel. I practice yoga and I watch cricket, which I don't think a lot of people here do that, but being an Indian makes me watch cricket a lot. It's in my blood. Here's my GitHub profile if you want to check out. I'm also there on LinkedIn and Twitter, very active on Twitter. So you can always DM me if you have any questions now and later. It's always, you're welcome to come and contact me. And I've written some blogs on Medium as well, so you can check that out as well. So let's look at Project Amber first. So Project Amber is like a stepping stone for pattern matching. It started the entire thing altogether. This slide may be a little bit outdated, but it was there in April and then now it has been updated. So you can see in the highlighted versions, the pattern matching has been delivered consistently in many releases. There's also another JEP, which is not included here, which is currently in progress. That's the third preview of pattern matching for Switch, which is going to come in Java 19. And Java 19 will be released later in this year. Records pattern, the JEP 405 is broken down now. It's just record patterns going to come as preview, and array patterns are going to come later on, but we will still talk about array patterns and how they will look like here. So let's first get into algebraic data types, which is records. Records are very interesting feature that came in Java. Records are immutable data classes that only require a type and the name of the field. So records are basically your immutable data types. You can use them. It's like your Pojo, which you used to write, and you used to write everything with that, like toString methods and equals method and hash code method. All those things are now compressed and you can use it as records, and these are immutable. So once you create it, you cannot change the values later on. Records cannot extend other classes because in implementation, it's actually extending a record class. So Java doesn't allow multiple inheritance, so it cannot extend any other classes. But you can use record with the multiple interfaces. So you can use records and can implement other interfaces as well. Records are not by default serializable. This is a design that's by design and not by mistake. This is done to actually protect your classes. And once you deserialize, all the constructors will be called again and again. So this is a really interesting concept that Java architects have realized to make it more and more secure. The Java Lang class API has been retrofitted to support records. So if you are using reflections and everything, so you can actually use isRecord method from the class API, which will tell you if your class is a record class or not. Records they generate public getter methods. So if you look at the implementations, the record don't need a setter because you are actually instantiating the objects right there when you are creating it. So you can't set the values again once it's created already. And this is where it is different from the ones you use with Lombok classes. So that's where the slight difference comes in. And records, so since you don't have the setters, you only get the getters, and the name of the getter matched with the name of the field. So that's pretty cool. So now here you see records as an example. Before, you have a driver license class where you have an age and you have a constructor, you have getters, methods, setter methods, you have toString and equals, and you can see it's a lot of code. I hope this is hard to read because this is intentionally done this way. Once you have records, you can just write it like this. And can you imagine how simple the code looks like if you look at this one and you look at this one? So this is one of the reasons as well, like bringing records in makes our job easier, and you're not having to write same type of code again and again, and you can focus on something which is valuable. The other algebraic data type is called the seal type. The seal classes, they allow the author of a class or an interface to control which code is responsible for implementing it. So basically your author, whoever is writing your main class, parent class, knows which are going to be the child classes. This is a very different concept, and you may think, okay, this is not allowing you to inherit it. No, that's not what it is doing. It's actually protecting it. It provides a declarative way, then the access modifier to restrict the usage. And restricting the usage of a superclass is important when you want to have, like, let's say you want to model your data. You want to create a hierarchy in your application, and you want to know the outcomes, the possible outcomes of your objects. That way, seal classes are very useful, and you can use them very easily. The next point that I'm going to say is going to affect, I'll show you in the later slides as well. It supports the future directions in pattern matching. So one of the reasons I'm describing records and seal classes before describing pattern matching is because this creates the foundation for pattern matchings to implement. So pattern matching is nothing but it's using all these records and seal classes, and it's much more than that. So in order to support these future directions, you'll get the foundational understanding, and it will give you the exhaustive analysis of patterns. We'll see that. To have the possibility of a superclass to be widely accessible but not widely extensible. And this is where I say that, okay, you're free to inherit any class you want. It will be accessible, but it should not be extensible. So if we have a shape class and you want to have implementations, you can have circle, you have line, you can have rectangle, but you don't need animal class to be associated as a subclass of a shape class, that won't make sense, to be honest. So that's why it's actually restricting. It's making the code less buggy. That's also another one of the reasons you may want to use that. So this is a few examples. I've also shown you how you can use records with seal classes here. So you have a seal interface shape, which permits circle and rectangle, and you have record circle and rectangle, which is implementing shape. If you try to add more, it will not allow you because it will throw you a compile time error. So that's what is expected out of it. Now let's look at pattern matching. So now we discussed the foundational understanding of Project Amber's most two important features, record and seal classes. And now let's look at this. So pattern matching is a technique that has been adopted to many different styles of programming languages. It's not new, like I said, it's been there since 1960s. So pattern matching, like I said, it's like a search something and match with a pattern which you want to, and then use it. So pattern and then matching. So it used to be very useful in text-oriented languages, and functional languages like Haskell and Scala and ML, they have also implemented pattern matching some time ago. It's been there for a while. It's very important in functional languages as well, because with functions being first-class citizens, you want to have a same input and a same output. That's what the functional programming paradigm says that. So if you have a pattern matching enabled in functional programming, it will allow you to actually being able to predict the values, what you are expecting out of a function. That's why it's actually more common in functional languages. So I have also added a link for the design notes for pattern matching from OpenJDK. This is what the definition is derived from. So pattern matching introduced as a preview feature in Java 14. So this is around the same time when we were introduced to records. So that's why I said we were given bits and pieces of pattern matching. So it did not was just blasted onto us like one feature came in and you just use it. They have been very patient with us for that. So it was introduced as a preview feature and then continued to be another preview feature in Java 15. In Java 16, they were introduced as a permanent feature, which is a type pattern. And we'll talk about type patterns in a few slides. It is part of Project Amber. Project Amber has been all about, making the code concise and better and making it much more readable and accessible. So it works very well with algebraic data types. Like I showed, you can work sealed classes with records and all these things, and we'll show you the examples how you can use these patterns as well. Like I showed, record patterns are coming in, and I'll show you the exhaustiveness of the sealed types as well in a few slides. So they work very well with the algebraic data types. And it works very well with functional programming. And this is a well-known fact since it's been used with many other functional programming already. So we already know about this. So one of the key feature of pattern matching, like I said, it's a mechanism for checking a value against a pattern. The outcome is known. When I say known, it will be like either it will match or either it will not match. It will be like a true or false. It won't be like it partially matches a pattern or a value matches like half the pattern or not the pattern. Either it will be here or there. It's 0 or 1, nothing else. So that's the whole concept of pattern matching. And it's very important to understand. So a pattern, what is a pattern now? So a pattern is a combination of first a predicate. So your predicate will say, okay, whether it can be applied to a target, whether it will be match or not match. That's a true or false statement. Once you match a pattern, your match will be deconstructed. Sort of your match is used somewhere. So a set of binding variables are extracted from a target only if your pattern is successfully applies to it. So this is where it divides it into two parts. The first thing is that you absolutely have to match the pattern. So if you see the statement below, you have an if statement and string-like object is an instance of string. That is your regular predicate. It has to come up with something with like true or false. On the right side, you see a binding variable, which is an actual string object. You can see, I've heard a lot of other names for this as well. You can also refer to this as a pattern variable, a binding variable. So these are like commonly used name. So the binding variable is important because the binding variables are activated when you actually the pattern matches. So when the left side becomes true, then the binding variables comes into picture here. So all of this is in one line. So now you may be asking, like, why do I really care about pattern matching? Why do you want to learn it? So one of the important features, important advantages of doing it is you'll get the clean code. I'll show you some examples as well, how to avoid it, how to make it better and better. You will avoid a lot of repetitions. You want to compare sometimes to which type of class you are checking for an object. If you check for an object and then you cast it to a type, it's a lot of extra lines that you write. So since I've seen a lot of features on Project Amber are geared towards, making the code clean, avoiding repetition, making developers' life more and more easier so that you can focus on the business problem rather than writing ceremonious code. And Java is already infamous for being a bit verbose. So that's what the architects have got that feedback, and now they are trying to make it better and better. And once you have the clean code and you don't have a lot of repetition in your code, your bugs will not hide. So you can easily get the bugs in place. So anyone knew that pattern matching already existed in Java long before it was introduced as pattern matching? It did. So usage of pattern matching until Java 14 was still there. You already knew the pattern class, the matcher class. So you have a string sample for pattern matching in a test string object. and you have a pattern. So this is where you are checking against a pattern. So you have a pattern where you want to search for any words in a string. This is your pattern. And then once you match, you want to match against the pattern as your string. So that's why it's pattern.matcher with the test string. This always confused me, by the way, when I was using this pattern matcher for the first time. I was always wondering, why is it 2 lines and not 1 line? Like, why is it not like test string dot search for something? But now it makes sense when I know that this is pattern and this is matcher. It makes more sense. So once you have a matcher, you can use the value here. So this is a very simple string because you are just looking for words, and all of the test string is words. So if you find a matcher, which it should, it will just print the value regex matches the test string. So that was still there. So the Java architects were still aware that this is a feature. It's required in string class because you want to search for certain patterns in a string, and the regex is the only way to do it in the strings, and it's actually used there for a very long time. So we talked about how problematic the code was. We didn't get into details before, so we want to get into details now. What was the problematic code before Java 14 when the pattern matching was introduced? So if you remember, you had to do an if check for any instance of, if you have to check for an object obj, and you want to test if it's an instance of an integer, you'll cast it, and then you'll use all these brackets and all these things to be used, and then you can use the value of int12, right? So this is like, first of all, I never liked writing this type of code because it's a lot of brackets, and even though the IntelliJ and every other IDE supports you, it's still like boring to write a lot of these type of codes, right? So this is kind of a problematic code, more error prone as well, I would say. Why it is an error prone code? Because it's, first of all, it's less optimizable. If you look at more problematic code on the right side, I hope it is unreadable as well. So when you look at the code on the right side, it's doing a format string, and it has a lot of if else conditions. It's checking for a lot of instances and casting it again, and then using the values. So this code is very less optimizable. And if you don't have a good compiler, your chain will go to n branches. So you will have n time complexity, even though you are just looking for a O1 complexity, right? This is not a complex code, to be honest. You will need to type, test, and cast unnecessary. So this is like if condition and then cast again and then use it. So it's like 3-step it's all repetition going on here. And the third important point is, like, you kind of miss the whole idea of what this method is doing. It's just doing a string dot format, nothing else. So if you have like some cases where you don't need it, sometimes it's too hard to look in that code and you can forget, okay, I missed one if else condition, or if I missed one something, or let's say if you don't need a string instance of test, you will still write it and it's going to be unnoticed. So your errors are going to creep in here a lot easily than other ways. And it's all a lot of if else test. And quite honestly, it's a very annoying if else test. So it's a lot of unnecessary code. It's actually hiding your business logic as well. And you're not focused on your business logic, you're just focusing on the ceremonious code that has to be written. So let's talk about the instance of operator here. We discussed the instance of operator, and let's see what it is doing. So you're already familiar with the equals method that we write for an object. For, let's say I have a point X and Y, point class X and Y containing X and Y, which is like sort of a distance. And I want to compare the two objects, which obviously I have to do a lot of times. So I have to write a lot of code like this. If it's not an instance of a point, then it will return to false. If it is an instance of a point, then I have to cast it. And then I have to check the value. So the ultimate checking of your two objects, point objects being same, is done on the return statement, x equals p dot x and y equals p dot y. So if you look at this, I remember every time I looked at this code, I would never wanted to write it. I would just ask the compiler to generate it for me. But if you try to read and understand, this is the only important thing going on is in the return statement. All the other things are unnecessary. So it's checking the object and just doing all those things, casting and declaring a new variable, and all it's doing is just using the newly created variable to do stuff, which is kind of a lot. So pattern matching, introduced as a final feature in Java 16, gave us a lot of benefits here, because now you see, you just have the return statement and you just added a line that checks your instance of point P. If it checks the instance of point class for object O, and ultimately, as soon as it checks it, it assigns the values P. P is your binding variable, and then you check and use the value if your object matches the values or not. So you are doing the entire thing, the predicate, the binding variable, and then using the binding variable to do some stuff right on one line. So this is really interesting, and this creates a lot easier. It makes it much more readable code than the other one. So the instance of operator matches your target object. Your target object is point P. And then to a test type pattern. So these are like test type patterns. The instance of operator is actually using a test type pattern. When you say test type, is because it's type of the object that it's checking. So that's a type of pattern. If your object is an instance point P, then it is casting to point type class and assigning the binding variable. The binding variables is in scope in the true block of the statement if, and not in the false block of the statement. So I'll show you what am I meaning by this last line in a very next slides. So let's talk about, first of all, let's talk about the binding variables in depth. So binding variables are just a special case of local variables. They are very similar to local variables, aside from the definition of their scope. Scope is where they change the meaning from binding variables. In all other aspects, the binding variables are treated in a very similar way as local variables, just like the brackets and all those things, the scope ends when the bracket ends. In particular, this means they can be assigned to, they can shadow a field declaration as well, just like a local variable will do. A binding variable are subject to definite assignment, but it will take one step further. The scope of the binding variable is the set of places in the program where it will be definitely assigned. This is called flow scoping. And this is where actually it gets different from the local variables, because you'll see the flow scoping here. So if you look at this code, on the left side, you know that the X, you are checking X instance of foo F. So your F gets definitely a scope in here, which means that you will assign some value to it. Basically, you'll use this value in this if condition and not use in the else condition. So what happens is you can, if you try to use object F in the else block on the left side, you'll get a compile time error. That's the flow scoping. So if you have a local variable above, declared above the if condition, you remember the local variable scope ends with the curly braces altogether. That's purely relatable. You have already been using it. With the binding variable, it gets different. Left side is fairly comprehensible. It's not that difficult to understand. It gets tricky on the right side, because on the right side, if you see, if you have an if condition and you're saying that this should always be false if it's an instance of foo object F. So your F object is not actually in scope here. It will not be definitely assigned here. That means the scope changes and your flow is scoping here in the else block. And it gets weird because if you try to use object F on the right side on the if condition, it will give you a compile time error. But if you use in the else condition, you will not get it. You will not get the compile time exception. So this is like very different from local variables, and that's something that you need to understand. And this is where I said the concept of definite assignment comes in picture. Okay, so we looked at the instance of already, and now let's look at the switch statements and switch expressions. So switch statements and expressions, Java inherited it entirely from C. I don't think I've used switch statements a lot in my previous, initial years, at least. Traditionally, because switch had a very limited usage, you can only use on a very small set of values like numbers or strings or enums, and you can only test for exact equality against constants. And this is a quote from Brian Getz that, but these limitations are mostly accidents of history. I think since they inherited from C, it wasn't much change initially, but Java 12 actually worked hard on introducing switch expressions, which like any expression evaluates to a single value. The switch statement or an expression is actually a perfect match for pattern matching, and we'll see that in coming examples. Before I go there, I really wanted to define what is actually a difference between a switch statement and a switch expression. And these are like key concepts, because you see the next coming slides, you'll see mostly I'll use expressions and how you can use expressions to actually work with pattern matching. So it was important to describe it here. The switch expressions were introduced in Java 12 as a preview feature, finalized in 14. This evaluates like any other expression. It evaluates to a single value. It can be used in statements as well. It also introduced an arrow case label, which eliminated the need to have break statements. Who else remembers the horrible break statements that we had to write when you're writing your case labels, and you miss one and it just falls through anything, and you won't even realize it because there won't be any compile time error, and you'll be like, okay, what happened here? What went wrong? So that was like one of the important achievement by adding switch expressions. And with arrow case, you can just write an arrow and just use it like a normal written code. It reduces a lot of complexity as well. It also introduced the yield keyword, which actually transfer controls. It also like returns the variable, so you can yield a variable and just enclose your switch expressions to produce a specific value. So now what we looked at the instance of from pattern matching. We saw it was pretty nice and everything was great. Everything was solved for us. But what was missing from just adding the instance of operator? We could have just done there and gone home and you'd be fine. But no, there's a lot missing. If you look at this instance of with multiple conditions, just like we described before, the code got a bit simpler, but not still a lot simpler. You still have a lot of if, else, and you see that it has gone to a simplified level that we have reduced one line each in the if conditions, but we still have a lot of lines here. And again, there's a tendency to forget what we were trying to do. We are just trying to do string.format for multiple object types, right? So it's still not easy. So what came in as an enhanced switch as a preview feature in Java 17? This is a lot simpler. If you go back in this line and you see all these if else, this looks much more readable. It looks much more better in terms, and you can find out bugs. So all you care about is finding bugs or finding out your business logic. And if I look at this method, I can easily see that all you're trying to do is trying to format into a string, trying to use a string.format and trying to use something like this. So it becomes much more easy and readable for me to identify if there are any bugs here, or if there's any case missing, or if there's anything missing out here. So that's another thing that Java 17 has offered you. The another thing which is very good with making switch statements and expressions better, initially, so if you don't write, as you all know, if you write a switch statement on an expression, and I'm testing it on switch condition on S, object S, and I have object S as null, it will throw a null pointer exception. That's not gone, by the way. It's still there. You will still get a null pointer exception because Java is backward compatible. So you'll still see it. So if you have to protect your objects, if you have to protect your methods not getting the null pointer exceptions, you have to write an if condition. That's a way of handling null in switch, and we can't get away from it because it has to be backward compatible. That's the first policy Java implements. So you have an if condition which checks for nulls and it returns and it doesn't do anything. Otherwise, if you don't find a null, it will just check for your cases and you can go on your way like you are checking switch statements or expressions. If you don't do a null check, it will throw a null pointer exceptions. So we introduce the null case label. A null case label is really an improvement because now you can just write the same code and you don't have to write an if condition before your switch. You can incorporate the null as a case label. So it's a case label which will be added, which can be used here. And of course, you want to write it on the top because if you add it to the second or third or anything below the first case label, it won't make any sense. If it has a null, it will actually go and check the first case label and it will throw an exception. So that's why it should be there on the first case label. That's important to understand. But it's a nice and cleaner way of writing a switch statements. So it's pretty good. The other thing is the guarded pattern. So guarded pattern, I'll briefly describe. So if you have like a condition along with your a pattern, so it's like a specified pattern that you want to match. So you want to match something as a triangle T, but you also want that your triangle T should have an area greater than 100, let's say. So all the large triangles should do something else in your code, and all the other possibly small triangles should do something else. And to differentiate between these two, earlier you had to write an if condition after the case label and then do all those things. We got rid of that, and we have guarded pattern, which can be used here just in a single line. So these are all switch expressions, and that's why you don't see any breaks in them as well. So it's pretty simple, neat, and clean. You're just doing anything you want to here. So selector expression typing. This one is very interesting because you see here, there are 2-3 things going on here. Number one, you cannot add the primitive types in between all your other object types here. So you see string is a class, color is a class, point is a class. Interestingly, int array, which is an integer array of primitive types, it's still kind of considered okay, but you cannot have case label int I and try to add it because the primitive types and the reference objects cannot be in the same switch. So that's one of the important features, but you can use them. Actually, for the primitive types, they said that they don't have a lot of use cases right now. It might be added in the future, but it's still not there. So since there's not many use cases to be used here, and switch cases are already being used with object types pretty well. So that's why. The other one that we should discuss is the dominance of pattern labels. What is the dominance going on here? If you see, you have, as usual, a null check on the first case label, null, case null. The second one is case string class. And if you try to make a more specific case in the next case label, it will not be allowed here. And there's a reason, because there has to be a sequence. If you remember, when we check for exceptions in the catch clause, we have the most generic one at the bottom and the most specific one at the top. So more specific gets the priority here. And that's one of the reasons you see the case label char sequence below the string sh. So this is kind of interesting to see. And you have already seen the exception, the catch exception theory. So you can correlate in a similar way. So more specific comes first, and that's why your case label with a more specific string case like guarded pattern will not work here, and it will not compile. So you have to move it above string sh. Okay, so now I have a question for those who are finding it sleepy or boring. If you find the problem in my next slide, you will actually win one IntelliJ license. I hear people are giving licenses here, so try to write the answers as soon as possible on the chat and be ready for it, and I'll give you some time as well. So good luck with that. So find the problem, and I'll give some time because I know there's some lag as well. So if you can find out the problem, why these two line of codes will not compile. I cannot see the chat, so somebody has to tell me as well.
Yep, that is going to be my job to tell you as well. While we're waiting for people to read and the 15-second lag, I want to mention that Ken noted in preview 3 and is now when, which presumably you know, but I think this presentation might have predated that fact.
Yeah. I have to add that. That's why I mentioned it verbally. There is a preview 3 for Switch coming in Java 19.
It's tricky. I don't know if anyone knows.
Come on, people. It shouldn't be that hard.
I know, but I don't want to give it away. I want one of our members to know.
It has, okay, I don't know if people are answering, so I don't know if I should give any hints.
Oh, we got someone. It's not the answer I would have given, but it's an answer. Bill said missing null check.
Okay, interesting. That's not the exact problem, but yeah, that's a good observation, Bill.
And we got someone who got it right. Doesn't have a human name that I can pronounce, but said no default. And someone else said null check and default missing. A few people are saying no default and no null check, so it'd probably be good to talk about both of those.
Yeah, that's a good point. So important thing to understand here, since Java has been backward compatible with all the features, if you don't add a null case label or a null check, it will not give you any compile time error, first of all, because there was never an error before for a compile time if you forget to add a null check here. But it's a good practice that you should avoid the null pointer exception. So you should add it. The case labels should be there. But that wasn't the problem really, because this code will not compile because it doesn't have a default value to return. So like I mentioned, it's a switch expression. So an expression has to evaluate some value. And since it has to evaluate value and you see the return type is integer, it has to return something here. And both the cases, like the first one, it's incomplete because it's not returning. What should it do? Let's look at the code and say, okay, what should it do if it's not matching as a case label string? The compiler is confused here. You're trying to solve the problem for a compiler as much as you can. But I really like the fact that people have noticed the null missing, which is something which I didn't see that as well. So good, that's a good thing. And whoever answered the first may win the license as well. So congratulations and good luck. So moving on, that was the solution. So since it has to have at least a default, even if you miss the first or the second case label, even if you add just a single case label, it will work very well if you have a default. But it has to have a default. So now we look at how it works with seal classes. So you remember when we were talking about seal class types, we said the exhaustiveness of the patterns here. Now you look at the code and say, okay, in the previous slide, you needed a default. And here you'll say, okay, there's something going on here because there's no default. And why is that? Because in this case, the compiler already knows what the exhaustive values are going to be. So you're checking it on a sealed class, which is class S, object S, and you're trying to evaluate all the case labels. And since the compiler is already aware well in advance that you define sealed class and you are permitting class A, B, and C, and it looks for, okay, all the case labels for A, B, and C are here. And since all of the case labels are here, you don't even need a default, actually. So it's actually working simultaneously with pattern matching because your compiler becomes really smart. And now it knows it doesn't need a default anymore, only with sealed types. So just remember that. So now I've already talked about instance of and switch expressions and switch statements and all. So now I wanted to just briefly add what are the type of pattern matching that has been so far. So there are two different types of patterns exist right now, and few of them are getting added. The primary pattern, which is first I talked about the type pattern. The second type of primary pattern is a record pattern. I'll show you in the upcoming slides as well. That's also there. The other type is the guarded pattern, which I showed you the primary pattern and your conditional expression. So you are just adding a more specific condition. You're guarding your pattern. So that's why it's there with and. And with Java 19, actually, you can replace your and with a new keyword, which is when. So it's coming in Java 19, still not there to be used, but this is going to be much more readable and easy to use rather than, and it will make more sense when you start using it. So that's I think, a cool new feature coming in Java 19. So we talked about the future, how it will look like. Nobody can predict the future. So again, I'll tell you, I don't take any responsibility if something changes, but hopefully this will be how the record patterns will look like. So we looked at the records, how to create a record. You have a record point P with X and Y and enum color, which is having red, green, and blue. And then you have a record which contains all these points, color point, and then a rectangle which contains the color point, which is upper left and lower right. So all you want to do is print your upper left color point and you pass in a record here. All it's doing is it's deconstructing your rectangle, which is a record. And that's why it's called the record pattern as well. And you're deconstructing the rectangle and getting the values directly. So you don't have to extract all the values, checking instance of all the time. It's getting easier and easier to just use it because if you see here, you deconstructed in the if condition rectangle. Now you have color point already, and you can use the color point and you have the getter method, which is the name of the variable, which is C. So you get the upper left color point very easily in one line. And this is saving a lot of time and energy you have to write to deconstruct one object. So these are layer of objects one onto another, and you can just deconstruct all of them at once. So it's easier. The very new pattern, I don't think it's coming in Java 19, but maybe later, is array patterns. So array patterns is very interesting because now you have, let's say you have you're using an object O and you want to check for an instance of integer array. And your integer array is basically S1, S2, S3, the three objects in an array as passed in. You can calculate the area without even using a for loop to extract the values. This is all returning in one line. So this is pretty cool and pretty neat. This is also known as one of the deconstruction patterns. So the naming you will hear a lot is related as well. There are a few references that I have given here. Also the JEPs, which I thought was very interesting. Some of the InfoQ articles also. And I think we are ready for some questions.
Okay, we do not have any questions so far. We do have a comment that Kotlin calls this destructuring, which I think a lot of people already knew.
Mm-hmm.
If there aren't any questions shortly, I know people may be taking time to think about questions. We could do some giveaways. We have 2 or 3 IntelliJ licenses to give away.
Right.
And we could do that by asking questions to the audience.
Oh, yeah.
What do you think?
Yeah, we can do that. Also, I want to mention, I don't think I mentioned it before. I know this is a lot to take in at times, because a lot of these features came in iterations from Java 14 up until Java 18 so far. So if you want to try out everything, you don't have to be confused. Just try out everything in Java 18, which is, since it's all backward compatible, enable the preview feature for sure. And you can use almost everything. I think the when clause, the when keyword is not there in 18. It will be introduced in 19. But up until so far, all these examples, you can try it out. Yeah.
Still no questions. Do you have any you'd like to ask the audience, or should we go to one of the ones I was thinking of?
I didn't think of questions much. Let me think.
You got to thank you. It's not a question, but it's definitely a comment.
Yeah, I want to thank everyone for coming here. That's always very nice to have people listening to you. And also, like, presenting at NYJavaSIG has been like my dream come true. So I'm very happy to be presenting here, even though I'm part of it already, but I still can't believe I'm presenting here. So I'm very thankful to the organizers as well, all of you guys.
Okay, now we got a question. I missed which limitations were in JDK 17 LTS.
So JDK 17 gave us the switch conditions. So let me go back here. So pattern matching for switch was introduced as a preview feature in JDK 17. That was the implementation came in, and 18 it continued as a second preview, and 19 will come in as a third preview, which is actually weird because I've not seen a third preview for a feature. I think they are just enhancing it. Like I said, pattern matching for switch will include when clause. So they are kind of making it more and more accessible and easier for developers to understand.
Okay. We have another question. Ashish wants to know, do you think Java could have done without the binding variable and use it like Kotlin does smart casting?
Yeah, that's a good question, actually. I think, I don't know the reason why they added it, but it makes it much more compatible in a way of defining a scope. So you can also think about it as if you don't need a variable in that if or else block, you won't want to use it. And obviously creating a local variable is an option, but binding variables kind of makes it compatible with the pattern matching analogy. So pattern matching analogy, say you find a pattern and you match it with a binding variable. So binding variable has to match and connect with your pattern only. So the scope has to be limited to the pattern only. And that's something that local variables cannot really define, because they are not doing the flow scoping as such. I hope that answers the question.
Yeah, that was a great explanation. And we are all caught up on questions. So I think we should ask the audience a question. Are you okay if I ask the audience a question?
Perfect, go ahead.
Because I had time while you were speaking to think about questions. So this question, the answer is going to be 1, 2, or 3 things. Which of these require an exhaustive switch if the result is assigned to a variable? So like, when do we have to have a default or cover all of the cases if we're assigning the result to a variable in a switch? It could be a string, an enum, or a Boolean. How many of those need to have an exhaustive switch? And it's okay to answer even if you already have an IntelliJ license. In the event you win, we'll just go on to the next person.
Curiosity is more important.
Yeah. Someone said string. Someone else said string. Looks like string is the winner. And string is correct. Ashish, Bill, do either or both of you want an IntelliJ license? If so, post yes in the chat. And to explain this, string definitely does. If you were sitting around listing all of the strings in existence, you would be very busy straight through until the end of time. Enum does not require a default because by definition, enums are finite and you can list them all. And finally, Boolean is not allowed to be used in a switch statement and was there to trick you.
Good one.
It's definitely exhaustive, but it can't be in the switch, and therefore it doesn't need a default because the code won't compile.
That's a good one, yeah.
Okay, so we have 3 people who answered the question correctly, and one of them wants an IntelliJ license, so we have a winner of the IntelliJ license. Ashish, Mike, if you want one too, you can have it, given that Mike answered before and Ashish was faster. I think we should ask one more question. Do you have anything in mind, or shall I ask another one?
You can go ahead. I'll keep thinking.
Like I said, I had time because you were talking and I was thinking. Let's do an easy one. In a what English word goes with a guarded pattern? If you were listening to Neha's talk, you should know the answer to this. What English word goes with guarded pattern? See Neha smiling, so I know you know. And we have a question which we'll get to right after people have time to type English words into the chat.
I have to open the chat as well because I'm not looking at it.
We already know you know the answer. Bill got it. The answer is when. Different Bill than the other one. Ashish answered case, which makes me think my question wasn't worded well. The guarded pattern goes with the if state. Actually, the guarded pattern goes with the switch, but case has been around since the dawn of time. So other Bill, Bill G and Ashish, if either of you want an IntelliJ license, put it in the chat. And meanwhile, we have a legit question. Mohammed wants to know, what are the development norms and standards with the recent version for Java programming language?
Okay, this is a bit abstract, but I'll try to answer. So different projects have different purposes. So Project Amber is having a couple of JEPs all together, which focuses on delivering a certain idea. Like they have a lot of things to do with making the null statements, expressions more accessible, make it more user-friendly. They added with records, they added with sealed classes. So it's all grouped under one umbrella of project, which is Project Amber. And other projects have other purpose as well, like Project Valhalla is there, Project, I forgot the name actually, for lightweight threads. I'm very lost today, sorry. But the different projects are doing a lot of bunch of works in many JEPs altogether under umbrella, but you can check out on the java.net or OpenJDK website. They have all the information there, so it's keep getting updated. You can also subscribe to their mailing list if you are interested in learning about any other features which are coming in.
Okay, cool. And we have one more IntelliJ license to give away. Since the people who have been answering the questions correctly mostly have IntelliJ licenses, this one is going to be easy to win. The first person who types the number 42 in the chat wins an IntelliJ license.
I also saw a question from Bill. Yes, the instance of has always been in Java. So it's nothing new. You always were checking for instance of if you're checking for a type of an object. But yes, the new features are making the usage of instance of very easy. So that's the difference. Yeah.
And congratulations to Yin Yang, our third IntelliJ winner.
Nice. Congratulations, Yin Yang.
Okay, I think we're out of questions at this point. So we're going to do closing remarks. Rodrigo had to disappear in order to celebrate his birthday because cake is far more important than anything else, but I'm sure he'll be watching this on video later. So in closing remarks, the winners are going to email us at info@javasig.com to claim their prize, and we will email you the license. Our next meeting will be in July or August. We are trying to have our first in-person hybrid meeting where you can come in person or watch online. And rooms are hard, so we're trying to nail that down. But we're really excited that we're going to get to see some of you in real life very soon. Did I miss anything in closing remarks, Neha?
I think you've covered it all. And really, again, I'll share the presentation. I saw a comment as well. I'll share the presentation as well. And the recording will be available as well. So feel free to reach out if you think about a question later on, because pattern matching is a deep topic, I would say. If you think about something which is not clear right now, you can think about it later. And obviously, we are very, very, very excited that we will be hopefully back in person soon. I have to see people. I'm kind of like holed up here. So I want to see people and meet people again. It's going to be very, very interesting. And I'm really looking forward to it.
In that case, I think we're going to end with a bit of humor. Shout out to Peter, who wrote, "Nice job. This was a good instance of New York JavaSig." That was very appropriate. Thank you, Peter. Thank you, Neha, for the excellent talk. And everybody, good night.